I'm Anil Kumar, and I hope you're enjoying this set of videos where we're trying to understand more about inverse function. Now, this particular question has been in the test paper a couple of times. I'd like you to make a note of it, try to solve it yourself, and then watch the video to understand the concept. Now, the question here is, given f of x equals to 5 minus x plus 3 whole square for x greater than equal to minus 3. Determine the equation for inverse of this function. And second part is graph the function and its inverse on the same axis. And let me now add to this, write domain and range for both function and its inverse, right? So these are the three parts which you should be doing. So what I will do for you is I'll basically tell you how to do these things in short. So let's now understand the question. It says, given f of x equals to y minus x plus 3 whole square for x greater than equal to minus 3. So basically we have restricted the domain. So that really means restricted domain, right? Normally when you have a parabola or a quadratic function, its domain is not restricted. X belongs to real numbers. So that is kind of important to understand. So if you see this, your vertex is at minus 3 and 5. The function is opening downwards because of this minus here, right? And now your domain is restricted, and domain is x greater than equal to minus 3. So let's start with kind of graphing this function first and then getting back into finding inverse equation. It is going to help you and understand the problem better, okay? So let's see how to graph this function. So we know the vertex. Vertex for us in this case is minus 3, right? This minus sign, and plus 5. So minus 3, 1, 2, 3, and plus 5 will be here. So that is the vertex. Now once you know the vertex, you can draw the parabola very easily. So I'll start with step function to draw the parabola. Since this is multiplied by minus 1, my steps are 1, 3, 5, 7 with minus sign, right? So it is minus 1, minus 3, minus 5, like that. Do you understand? 1, 3, 5, 7 going negative. So if I move 1 unit to the right, I have to go 1 unit down. That is minus. And from the symmetry, I know my next point also on the other side. So this is my line of symmetry, right? I hope you appreciate that part. And so I got the top half. Now the next point when I move to the right, I have to move 3 units down. So 1, 2, 3. So that's my next point. And from the symmetry, let me put 1 here. Next point when I move, I have to put 5 units down. 1, 2, 3, 4, 5. There you go. And then we move from here to this place. So we have our parabola right there, right? And so it moves down. So we can connect these points. So top half should not be a vertex. Should not be a corner. So the vertex should be smooth when you are drawing a parabola. So let's draw this and extend this. And always draw arrows because it extends to infinity when it opens on either side. So this is opening downwards, so it will go to minus infinity. So that is how we have our function. As you can see from the function itself, its domain is all real numbers. But what is given to us? It is given to us that x is greater than equal to minus 3. Do you understand? When we say x is greater than equal to minus 3, then we are only considering 1/2 of the function, right? So we are not considering that half at all. We are considering this half. So let me draw this double line. Do you understand? So this is the part of the function which we are really interested in, not this. Do you get that point? So if you have to draw this function, truly speaking, you should draw only the right half, right? That is, we are only saying x is greater than equals to minus 3. So that means including this point, only this side. So now that is the half which you should have drawn, and that is what I expect you to draw. You should do this, if at all, dotted lines. Okay, so we have our function, that is this function, which is combination, which is kind of bolder, is the function f of x, which represents 5 minus x plus 3 whole square, where x is greater than equal to 3. Now we can write domain of this function here. So the domain of this function is, domain dx is given to us, x belongs to real numbers where x is greater than equals to minus 3. Now you can see the range of this function also. So range of this function is that y belongs to real numbers where y is less than, right, because of this negative sign. So y is less than equal to the value 5. So that is how you get your function. And from here, if you think about your inverse function, right, so what will be the domain and range for inverse function? Think about it. In inverse function, it is going to swap. So for inverse, what will happen? The domain will become less than equal to 5. So the domain d of inverse will be x belongs to real numbers where x is less than equals to 5. Do you see that? That is this swap, right? This swap. And therefore, the domain is going to be this. And the range will be that. So range of the inverse function Ry is equals to y belongs to real numbers so that y is greater than equals to minus 3. So I did this part first for you so that you understand where we are going, right? And now we will work with the equation and find the inverse. Now, do you understand? So we are looking for a range which is less than minus 3, coming downwards. Do you understand? Not going upwards. That is what the range should be when you swap it. Do you see that? Now, we have still not drawn the graph, the inverse on the same axis, which we'll leave for you to do, okay? Which you could do by flipping the points or making its image on y equals to x line. Let's get into the equation part. So the equation given to us is y equals to 5 minus x plus 3 whole square, where x is greater than equals to minus 3. To find inverse, we have to interchange x and y. So we get x equals to 5 minus y plus 3 whole square. Now let's solve for y. So we'll do x minus 5 equals to minus y plus 3 whole square. Now we'll do minus multiplied by, so it becomes 5 minus x, right? Or you could have written minus of x minus 5, but 5 minus x, and we get y plus 3 whole square. Now we'll do square root. So when you do square root, then you have to take plus and minus. So square root plus and minus 5 minus x is equals to y plus 3. And now from here we can write y equals to, take 3 on this side, minus 3 plus and minus square root of 5 minus x. Now I have found this inverse of the function. Can you tell me what mistake I have done? In this calculation, we have done a mistake. So you need to find out the mistake which I have done here. So that's kind of very important for you to understand. Now the mistake here is, if you land up with this, then you are saying that the inverse is having complete range, right? Plus and minus. That means there is no restriction on the range, but actually we calculated that the range is restricted. It is always greater than equals to minus 3, right? So that is the range which you should have expected, but it doesn't reflect here. Do you see that part? So why? So that means we did a mistake, and do you know what is the mistake? The mistake is right here, right here. Now, when you are considering this function, that is x is greater than equals to minus 3, see, the domain part is correct for you. Domain part is correct because you are saying x is less than equals to minus domain is x is less than equal to 5. That is correct. If x is more than 5, you get negative here. Correct? So domain part is correct for you, but the range is still not correct. To get the right range, what you should do? We are expecting a range where y should be greater than equal to minus 3. So that means we want plus sign. We do not want minus sign. Do you see that part? So that is kind of important to understand. So when you have a restriction which is kind of like this, then you should not take plus and minus both the signs. You have to take only the plus sign in this particular case when you are working on greater than side. If this was less than, you would have taken minus sign. Correct? And now I'll write down the answer for you, which is f inverse of the function is minus 3 plus square root of 5 minus x. Do you understand? That is the result, right? Well, I would have actually preferred to write this answer as minus 3, I wrote minus again, plus of square root of minus x minus 5. So that was actually a better answer for this particular question. But in any case, the important thing here is you have to consider only the plus sign and not both plus and minus when you do square root for a restricted domain function. Do you see that? So that is how you have to do it, and keep in mind that when we have a restricted domain, we are only considering one half of it, not both the half. Do you understand? You have to control only one half of it. Now, to sketch the inverse, you could flip the points or you can flip it on the line, which is y equals to x, right? So I'm just sketching a line here so that we get our inverse function. So we will now sketch inverse of this function using flipping points, right? So this on the line is invariant. So this point, we'll leave it there itself. That point seems to be 1 unit there, so we'll take 1 unit. Reflect it on y equals to x line. So you get another point here. Now the vertex is at minus 3 and 5, right? So when you flip minus 3 and 5, so it becomes 5 and minus 3, right? This is, let me write down here. The point is, vertex is minus 3 and 5. So we are looking for a point which is 5 and minus 3. So we get 5 and 1, 2, 3. So that is the point we are looking for. So that is by flipping. The other way is by going as a reflection. So let's reflect it. 1, 2, 3, 4. Do you see that 4 units? So my vertex is 4 units to the left side of the mirror. Let's go 4 units down. 1, 2, 3, 4. So you reach the same point. Do you see that? Similarly, you can do the next point, which is 1, 2, 3. 1, 2, 3. So you are here, that point. Do you see that? So that is how we are getting all these points. Now flip this point over. So this is on the y-intercept. It should fall on x. See how? 1, 2, 1, 2. There you go. Do you get the point? So you can see from here that your domain, now your function, if you join these points, it is kind of like this. Let me join this way. Do you see that point? So that is the inverse of the given function. This is the inverse of the given function, right? That is the inverse. Now you can clearly see from here that the domain is x values less than equal to 5. Do you see that? And the range is more than minus 3. This is minus 3 for you. Do you see that? So minus 3 plus something gives you the answer. That is how you get your inverse on the same graph. And that is how we get our inverse equation. Now let's recall what we did. Now basically, if you get a function which has a restricted domain, I would like you to write down domain and range first so that you have clear idea of what you are getting into. So from here you know clearly that the domain is x less than equals to 5, kind of. Do you see? Less than equals to, you are expecting something on this side. And you say the range is greater than minus 3. That means over this place. So that is the portion where you are expecting your graph. Now you do the normal thing of finding inverse. That is, write on your equation as y equals to something interchange x and y, find what y is. But remember, when you do square root, only take positive sign, not the negative sign, otherwise you have made a mistake. And then write down f inverse only with that positive sign. When do we take positive sign? If we say restriction is x greater than equals to, then we take positive sign. If we write x less than equal to, then we would have taken negative sign. Keep that in mind and then continue with the question. I hope that helps you a lot to understand and get the concept of finding inverse of restricted domain. You'll notice one thing, that the inverse is a function. Do you see that? So this is another way of making inverse a function. I hope you appreciate it. Thanks and have a good time. Bye.